Hey everybody, welcome to this video. I'm Gunnar with Decodable, and today I would like to show you how to get started with Apache Flink and FlinkSQL. Now, when people hear about those technologies, oftentimes they're very excited about their capabilities, stateful stream processing. And at the same time, you might not be quite sure how to actually get started, how to deploy your first Flink cluster, how to set up your first Flink job, or how to run your first Flink SQL query. You might have all those kinds of questions, and this is exactly what I'm going to show you in this video today. All right, let's do this. So what I would like to show you today is how you can use Apache Flink for taking data out of one Kafka cluster, modify it a bit, and put it back into another Kafka cluster. But I shouldn't really say Kafka cluster, but rather RedPanda cluster. Because RedPanda, that's the streaming platform which we're going to use today. RedPanda, that's an alternative implementation of the Kafka protocol written in C++. It is very fast and memory efficient and provides you with low tail latencies. It also doesn't require a zookeeper, which makes it very easy to run and operate. So RedPanda comes with a nice command line client, RPK, which we can use for interacting with RedPanda clusters. So let's use this for setting up a RedPanda cluster with 3 nodes. And this takes a little bit, and then I have this 3-node cluster running. I see all their URLs here, and I can export them into an environment variable, so I can use the RPK command a bit easier later on. And all this is backed by Linux containers, so if I take a look using Docker PS, I see those containers running. Now I can use the RPK command for creating a few topics, and I want to create them with a replication factor of 3, partition count of 30, and I create 2 topics, input topic and output topic. So there they are. And if I now use the RPK cluster metadata command, I can see all the information about the cluster and those topics. So now let's create our actual Flink project. And for that, I'm using this Flink quick start archetype, which essentially is a project template. And this generates this new Apache Maven project for me, which I just can quickly build, so to see everything works out nicely. And then I can import it into my IDE. All right, so here I am in my Eclipse IDE, and I'm importing this project. And the first thing I want to do is I want to change a few things in the generated Maven POM file. So I would like to use a Java 11 as the Java version. I can take a look at the dependencies which are there. So there's my Flink dependencies, which I'm going to use. And I also would like to work with Kafka. So let me add this Flink connector Kafka dependency. And then there's a bit of generated configuration for Eclipse, which I don't really need. So let's just remove this here from the POM file. Now we can go to this generated job class and start to work on our job definition. And the first thing we want to do there is we want to configure checkpointing. So this is about making sure, or configuring the behavior in case things go wrong. This job needs to restart it, and it needs to restart from a defined context. So this is what's happening here. Every 1 second, we want to do this checkpoint. Then I'm setting up a Kafka source. So this is what connects to our Kafka topic. It uses the input topic as the topic name. And I need to configure it with the Bootstrap servers. So here I just take the URLs from my RedPanda progress, put them into a variable, and now this Kafka source will read the data from that RedPanda cluster. The next step is setting up a stream. So I'm using this from source call, and there I define what's my source, the Kafka source in this case, what's my watermarking strategy. We don't care about late arriving events, so we use no watermarks, and we give it a name. We put that into a data stream object, and now we can actually make use of the Flink stream processing API. So let's say we want to filter our events. So we can use this filter operator and, for instance, only keep those events which contain some string, let's say foo in this example. And also I might modify my data. So here I'm just converting all the messages to uppercase just for the sake of the example. Having set up the stream, I need to put it into some sync, and to begin with, I'm just using a simple print sync, and here I'm using this true parameter for the constructor, which means everything which will be printed out on the error output in a red color. So just we can nicely see it. And lastly, I need to connect my stream to this print sync. Having set up all that, I can actually run my job. So let's run it right here in the IDE. And now we can start and produce some messages to this Kafka topic. And for that, I'm using this RPK topic produce command. I specify the topic name, and then I put just some example data there. So a little bit of JSON, which I'm pasting here. And now we see it shows up on the error outstream of our application. And to make it repeatable, I'm just using echo and then I pipe it to RPK topic so we can run this again and again. And as I do this, I see all those messages show up in the error stream of my application. Now, let's take it one step further and actually take the data and propagate it to another Kafka topic. So for that, we remove this print sync and instead we use a Kafka sync. And this Kafka sync, this is connected to our output topic. It's also connected again to our Bootstrap servers as before. And now, if we run this one, it will take the data from the input topic, apply the filtering, apply the mapping, and write them to the output topic. So let's run it again, and let's use RPK topic consume to read from our output topic. And to make things a bit more nicely to read, I'm piping the output to JQ. So I see my output there. I already see it's uppercased. And now, if I send more messages to our input topic, they also show up on the output topic, as you see by the changing timestamp in partition. All right, so now let's take things to the next step and deploy the job in an actual Flink cluster, because in reality, we wouldn't want to run a job from within our IDE. So you can go to the Flink website, download the Flink distribution. This takes a little bit. Once you have downloaded it, you just can unpack it and start up a cluster using the start cluster script, which is there provided for you. Again, this takes a second or two to bring up the cluster, and then you can actually open up the Flink web UI in the browser. So on localhost 8081, you will see this UI. It will show you all the deployed jobs, their status. You could restart them and so on. So now let's actually deploy our job. So for that, we need to build it using MVN clean package. This creates a self-contained fed jar of our job with all its dependencies. And then we can use the Flink run command to upload and start the job. So we need to specify the job class and the path to the jar, submit it, and then it will automatically show up in the web UI after a little bit as a running job there. So now let's see whether it actually works. So for that, again, we can take a look at our topic producers and our topic producer and our topic consumer. So let's launch them again. And now, again, we should see those messages arriving on the output topic. And if you look closely to the timestamp and partition fields in the output topic, you see those values that change as we send new messages. And lastly, let's just, as a good measure, cancel the job again. Of course, we could keep it running, but here to leave the cluster in a clean state, we cancel it, taking the job ID from the UI, and then the job will automatically show up as canceled in the web console. Finally, let's deploy the same sort of stream processing logic using SQL. For that, we are going to use Flink SQL. And as we are using Kafka, we need to download a dependency there, the Flink SQL connector for Kafka. So let's just get that. And now we can run the Flink SQL client, adding that jar which we just downloaded essentially to the class path. So let's bring up the Flink SQL client there. And this gives us now a prompt which lets us run SQL queries against our sources in Flink. So first of all, let's create a table which represents our input topic. So there we refer to our Kafka topic with the name, Bootstrap servers, and so on. We describe the structure with order time, order ID, and so on. And now we can query that table. In this case, we just take a look at all the rows, which it essentially has. And now this is updated in a live fashion. So as we send new messages to the topic, you see that in the Flink SQL UI, that those records, those results are interactively updated and shown. And of course, we can now apply all the capabilities of SQL. So just for the sake of the example, let's apply the same uppercasing transformation just to the city of the address row there. Let's select that from the input topic. And now you will see all those results have an uppercase city there. And if we push another message to the topic, again, we will see this additional row. And of course, now having those results there in the Flink SQL client by itself, that's not so interesting. So let's again close the loop and take this data and put it into our output topic. For that, we create another table, output topic, and this is a select based on our input topic table. If we create that, automatically a job is deployed to Flink, as you can see in the console. And again, if we put more records to our input topic, the messages will show up on the output topic on the lower right-hand side. And there you have it. Within roughly 10 minutes, we have built our first Flink-based stream processing application. You have seen how to run Apache Flink, how to use its Java API, and how to make use of Flink SQL. And really, that's all you need to get started with Flink development, and I'm sure you can take it from here. Now, if you would like to learn more, I would recommend you very much to check out the Decodable Examples repository on GitHub, where you can find the source code of the demo you've seen today, but all the other examples around Apache Flink, or Decodable as a fully managed service based on Apache Flink for stream processing. If you like this video, please subscribe to the channel, hit the like button, and if you have any questions, please put them either below in the comments or hit me up on Twitter. I wish you a very wonderful rest of your day and happy streaming!